A concentrated binary solution containing mostly species 2, but x2 is not equal to completely equal to 1. Or it is having the solution is having mostly component 2, which is in equilibrium with a vapor phase containing both species 1 and 2. The vapor phase is having both 1 and 2 in appreciable amounts. The pressure of this two-phase system is 1 bar, which is a for this pressure, the pressure and temperature are given. At this temperature, this H1, this is nothing but the Henry's law constant. For the component 1, H1 is 200 bar. And for the component 2, we are given with vapor pressure. Or is for component 1, we are given Henry's law constant, whereas for component 2, we are given with vapor pressure data. We are asked to find a good estimate of X1 and Y1 and what are the assumptions you made in this. So here, let us again go through a concentrated binary solution containing mostly species 2, which means the liquid is predominantly component 2. So always you can say like the 2 is approaching the solvent state, solvent condition. We have nearly 2, mostly 2, which means in the solution, 2 is the solvent. In the liquid solution, 2 is the solvent. And one is the component 1 is considered as the solute in the liquid solution. Okay. So otherwise, we know from our understanding about Henry's law and Raoult's law. For the Raoult, Raoult's law is applicable for the solvent and Henry's law for the solute. This component 1 is the solute and 2 is the solvent, because the concentrated binary solution containing mostly species 2, which is in equilibrium with a vapor containing both 1 and 2. That is, vapor is containing 1 and 2, but the liquid is having mostly species 2. That is, 2 is the like a solvent. Solvent is one which is available in plenty, and the solute is available in little amounts. So this information we can get from this first statement. So for the solute, we can apply Henry's law. For the solvent, we can apply Raoult's law. Now that is our understanding from the applicability of Henry's law and Raoult's law. So we are going to write Henry's law for this component 1 and Raoult's law for the component 2. So there is Y1P equal to X1 H1. This is for the solute. And Y2P equal to X2P2 set. This is for the solvent. So since you can consider this vapor to be an ideal gas mixture, so you can simply add these two without having any activity, fugacity coefficient and all. There is Y1P plus Y2P. That is simply equal to simply P, because Y1 plus Y2 can be taken out. So this is the final equation we are getting. Now, what is at last needed is we need to get X1 and Y1. What is a equilibrium composition? Before that, of course, we are given with H1 P2 set as well as P. Are we having that? Yeah, this system pressure, vapor pressure, Henry's law constant. So all are available. So using that, you can have this. So pressure is 1 atmosphere, 1 bar. Total pressure is 1 bar. Okay. So and vapor pressure is 0.1 bar. So using that, this in the expression, except X1, of course, everything is known. X2 is simply 1 minus X1. So from that, we are getting this X1, which is nothing but the this fraction, mole fraction of solute in the liquid. X1 refers to mole fraction of solute in the liquid, which is coming as 0.004502, which is how much percentage? It is only 0.45%. The component 1, the solute is having only 0.45% in the liquid solution. Okay, that X1 is available. Then make use of this expression. We need to get Y1 as well. No? So X1 is available from this total pressure expression, which is simply one is having Henry's law constant, another is having vapor pressure. So this vapor pressure term is there for the solvent term. The Henry's law constant is there for the solute thing. Okay. So by using that, we have this now. Of course, X1 is calculated. Then Y1 is X1 into Y1P equal to X1 into H1. So nice problem. Of course, this is based on our. So what are the assumption we had? We are assuming vapor phase to be a ideal gas mixture. Otherwise, we don't have any phi a hat. Otherwise, we don't have any phi a hat. Phi a hat is simply taken as 1. Okay. Then we are assuming the validity of Henry's law for the solute and Raoult's law for the solvent. Of course, there will be slight deviations. In what way? This is gamma 2 will be there. If you consider a wider range of, if the composition of the solute is still increasing, then you'll be having gamma 2 will also coming in. In that way, actually we are making an assumption that the solution made up of this component 1 and 2 is making a ideal solution. Otherwise, for the component 2, we are simply applying the Raoult's law without any modification. Of course, this is valid. This to be valid, this gamma 2 should also take the value of 1. So that means you are in the highly, the component 2 is in predominant amount. That is also coming now. Component 2 or is component 1 is only about 0.45%, and component 2 will be 90. What is it? 0.45 or is 0.5% means 99.5% is component 2. Fine. So that is definitely applicable. So this whatever the suggestion, justification or is whatever assumption of this Raoult's law for the solvent is applicable because we have predominantly component 2 in the solution, in the liquid. And vapor phase also can be considered to be ideal because we have the Y1, or is normally this is valid in the pressure range, low pressure range. Normally in the pressure of 1 to 10 atmosphere, the vapor phase or the gas phase can be considered to be a ideal gas mixture.